Where were we at here? This used to be a problem because, you know, older computer systems worked almost exclusively in octave first and then hexadecimal because they wanted or they needed, the simpler computers needed a system, a numeric system that would be represent an entire byte. So that's why they went to 8 first and then 16, base 8 then base 16. The newer computers don't really, they kind of hide all that from you so you don't have to worry about it. But back when I first started, we had to know how to do this, and we generally kept charts, templates that would, and these were paper templates or plastic templates, where we could say, okay, so 99 in decimal is whatever, 3F or whatever in hex. And we had to be able to do these conversions. Eventually, someone figured out we're programmers. We can write a program to do the conversion for us. And you don't really need to worry about hex that much anymore. It's kind of a lost art almost sort of thing, since modern computers hide all that from you. But we'll just go ahead and run it. And we'll see. I enter a decimal number, and I think I said 15 is F, right? Right there. And then we can go and we can run it again. How about 100? What is 100? 100 is 6-4. It's not 64, it's 6-4. And if you run it again, let's just give it a larger number. Let's say 1110 is 6E. You see that there? 6E? So 6E would be hex. So it gets confusing. Fortunately, you don't need to worry about it too much anymore. It's given it as an example, so I'll show it to you. It's probably more important from an historical point of view than, you know, anything current. Decimal or well, we did enter. Oh, you mean a fractional portion? That would probably cause an error. Hex is really for whole numbers. A negative. What if you a negative number? Let's find out. I don't think hex is intended to really have negative number. Let's see what happens by negative 9. You get negative 9. That's okay. It would be negative 9. Let's enter negative 12. Is okay. Hex generally isn't intended to be used with negative numbers, so it generally does not work. And like I said, it's somewhat of a lost art because modern computers hide the whole thing from you. We got this next one called overloading, and we'll take a look at this in a moment. Let's bring it up. Test method overloading. And I think this one's got an error. Okay, so here's an example of overloading. We'll show you how this works. Here we've got 3 methods max. And you see there's 3 of them. And you say to yourself, well, if I call max up here, which I'm going to do, how does Java know which one of these maxes to call? Recall earlier that I said that a method's uniqueness is determined by its signature. Remember I said that earlier. I told you to remember that. It's important. This is why it's important. Java determines which version of these 3 max methods to call based on the method's name, based on its entire signature, which is its name and its formal parameters. Well, Java can figure this out because it's got max with 2 ints, max with 2 doubles, and max with 3 doubles. So that's essentially the uniqueness of these methods. So when you call max with 2 integers, it looks for max with 2 integers, and that's the one it calls. When you call max with 2 doubles, it calls max with 2 doubles. And so forth. When you call it with 3 doubles, it calls max with 3 doubles. So, because again, remember, the signature is the uniqueness of the method, and the signature is made up of the name and the formal parameters. You want to remember that. because that's usually on a test. Okay. So you say that you've seen it in game programming. That's probably true. Yeah, most devices are done in hexadecimal, even to this day. Let's run this and you can see how it goes. So it tells you the maximum of 3 and 4, and it's able to figure it out. So there are some even better ways of doing this. We'll learn later on that there are actually some better ways of doing this. But this is what we mean by method overloading. We say that a method is overloaded as soon as you use that same method name 2 or more times. As soon as you use max the second time, you've now overloaded max. You've created an alternate identity for max. Right? So which max is it? Well, we figure that out by comparing the signatures of all the maxes. And that's how we figure it out. And that is essentially method overloading. Using the same method name more than once, 2 or more times. All right. So we can see this here. Ambiguous invocation. Any questions so far on that? So sometimes you may accidentally create a method that does not have a unique signature. So you create 2 maxes and their signatures are not unique enough. This would be ambiguous invocation, meaning there's 2 or more possible matches. Or the compiler can determine the most specific match. And actually, you've got it here. So, for example, right here you see max with 2 integers and max with 2 doubles. Well, you could say that's unique. That's true. But if I rename this max to something else, does my max that passes 2 integers now cause an error? No. The reason for that is because Java knows that it's okay to promote an integer to a double. So because this max has now gone away or been renamed, it will simply pass the 2 integers to the max that takes 2 doubles. So this will still work just fine. And that is what we mean. You'll see, though, that the result now is in the form of a double. Right? It's in the form of a double. And that's ambiguous invocation. However, if I do just the opposite, and let's just run this one again so you can see that the 4.0 won't be there this time. So if the invocation is ambiguous, Java will figure out the best match. So since you're passing in integers, integers would definitely be the best match. If it can't find the integers, then it'll say doubles will do, because a double is a promotion, and a promotion is implicitly allowed. Now, what if I do this? Now I've got an error. The problem is, while an int can be promoted to a double without any issues or questions at all, a double cannot be demoted to an int. Demotions are not automatically allowed. So that's why we got the error. And a double to an int is a demotion. Okay? That's essentially what they mean by this ambiguous invocation. All right, so that's what's happening here. Ambiguous overloading. I think I just showed you that. This one doesn't seem like it. Reference to max is ambiguous. All right. What method? Int double. Well, now here's the problem. This is not going to work. Because what's happening here is Java is essentially telling you, I found two I can use, but they're a tie. And I don't know which one to use because it's a tie. Right? So we've got two integers being passed to a max that takes an int and a double, but we've also got a max that takes a double and an int. So you've got a promotion one way or the other, but essentially Java is saying these two are essentially equal, and I don't know how to break a tie. And it doesn't. It doesn't know how to break a tie. If one is clearly superior to the other, Java will pick that one. But in this case, it's essentially a tie. And Java's like, I don't know how to break this tie. Right? So that's why you're getting this error, and this won't work. Java won't just decide, well, it's a tie, then I'll just take the first one. It won't do that. If there's a tie, it's just going to say, no, you got to fix this. And you simply have to fix it. So that's really ambiguous overloading. Scope of variables. A local variable, a variable defined inside of a method. So a local variable is a variable defined inside of a method, and pretty much so far all of the variables we've used have been local variables. Scope is the part of the program where the variable can be referenced. The scope of a local variable starts from its declaration and continues to the end of the block that contains the variable. A local variable must be declared before it can be used. Okay. So what do we mean by all that? Let's see if we can find a better example here. GCD, this is a method. This is where the local variable is declared. So these are all local variables. I think pretty much all the variables you've used so far have been local variables. And so we would say that these variables, since they're declared inside of GCD, can only be used there. Now, this is not a really good naming convention, I don't think. Well, anyway, let's just try this out. So I can't say down here, k is equal to 1. Because it's saying, if we look at it, cannot find symbol, variable k. If I move it down here, then I'm okay, because k is declared here. So these method names are like a solid brick wall of separation between each other. Kind of like the separation of church and state. Solid wall of separation. Right? What's done in here is done in here and is not available anywhere else. It's a solid wall. Right? No sound passes. It's a solid wall. This local memory is only for here. So that's scope. Let's see if they give a scope of local variables. You can declare a local variable with the same name multiple times in different non-nesting blocks in a method. But you cannot declare a local variable twice in nested blocks. Let's see what they mean by that. Okay, so it's saying that if you're nesting, each block has its own scope. So I can go and say int k equals 2, like that. That's already defined, so you can't do that. I didn't think you could. Let me read what this thing is saying here. Oh, okay, so I misread that.